सर वो कहाँ चला गया? वो वेबएक्स कहाँ चला गया? वो हट गया है।
सर
स्टॉप करके दोबारा करिए।
So see, this is very important paper in the graph signal processing. So this is the very this is the very basic paper one. What it has been say, I recommend everyone that you please go through this paper at least 10 times because such a beautiful paper, such nicely written, where all the concepts have been elaborated. Actually, it's a tutorial paper. It's not exactly a research paper. So what has been shown here, see if you see here the emerging field of signal processing on graphs. It is saying that when signal processing has been applied on a structure like graph, so that has been shown here. So when you will go through it, as yesterday, it is in the part of the IEEE Signal Processing magazine. The magazine basically introduces a new issue, new topics where these things are explained. So this is paper of 2030. And see, even that was the same time when I began. See, at that time there was no work, almost no work in the GSP. But this paper helped me a lot based upon my earlier experience of the DSP and the new concept. Only this paper was available at that time when I started my thesis. So it has been shown here that it is showing, see this representation. What a beautiful representation you are seeing. This is basically a star like a structure where this red is marked as the nodes, vertices, and these blue are basically marked as the values, and all are basically connected. They are basically connected here. In this part, see, when everything was simply a concept, people had been thinking that whether can it be applied at a concept level. So many challenges were there. What challenges were there? See, it has been shown here. Modulating a signal on the real line, how we will find the frequency. So many things were there at that time. So you will get into the detail, how the things actually work. Thereafter, here it has been shown that what is the graph spectral domain. Actually, see, remember, representation is one part, but whenever you deal with the mathematics, whether is this mathematics leading to any meaningful thing, see, that can't simply come by one calculation. It needs to be supported by many other, we say, other concepts. So here, spectral graph theory was a mean. This was basically concept when you will read it, when you will go into the detail in 1999, it was basically introduced. And in the undirected graph which we are using, there it has the main base. In the directed graph, it is another type of mathematics is used that we are not discussing in this work. Then thereafter, weighted graphs and graph signals have been explained. See, what is this one? What do you mean by the weighted graph? Weighted graph means where weight is there, and graph signals. Because so remember, see, this was basically the weight. This is one of some of the weight. And if you would have noticed that even in our EEG signal, we also took up the same weight. Why this works? You see, this actually Gaussian weight simply tells that if two things are nearby, then they have the more impact. That's why it is there. Distance ij it is less. And if they are far away, then it has the reduced impact because it is minus a distance square. That's why most of the time Gaussian weights work well. But not only you need to take Gaussian weights, but other weights also you can take. If you would have noticed a signal or function, what is graph signal? That has been clearly defined. Even that is the same thing which we discussed yesterday. It is defined on the vertex of the graph, represented as a vector. So what is saying that where the ith component of the vector f represents the function value at the ith vertex in graph signal in figure in one such example. I am telling you, it took me around a month, 1.5 months to understand what is the actual graph signal. Today, see, it seems very, very simple, but once you go through these things, go through all the representations, it really takes a lot of time because we have not seen that thing earlier. Graph Laplacian. Remember, when we are saying the graph Laplacian, it is basically the unnormalized graph Laplacian. How we are basically finding out it? We are basically finding out it with the L equal to D minus W. Please note it also one thing that in this paper, the representation has been done very clearly. You are seeing the D and W, both are in the dark, both are in the bold. So whenever you need to represent the matrix, it is basically dark represents the matrix. L is also dark, D is also dark, W. So that has been shown here. But remember, if you really see graph Laplacian is an operator for any signal. What type of operator? Where the neighborhood values difference is taken. How does it operate? Because if you multiply Laplacian with the signal value, then you will get this thing, Wij Fi minus Fj. If you recall, see, we discussed that relation yesterday. So that has been shown. Thereafter, see this line graph Laplacian eigenvalues are ordered as this. So what do we do? See, what is the use of this Laplacian matrix? Use of Laplacian matrix is the one that we are able to find out the eigenvalue. We find out the eigenvalue and the eigenvector, and these eigenvalues are basically the frequency that has been shown here. Graph Fourier transform notion of frequency. Once so that has been shown here, whatever in the details, if you really want to understand how the frequency concept come, what does it actually mean in the real, so that you can all see here. Because here in our workshop, we are mainly focusing upon the application part, that how we can do the applications. So here these examples are shown. See, uh, all you can see, imagine a scenario where, see, today it is very difficult to see, appreciate the beauty of this paper. But when I took up this paper, no work was available for the GSP. Only this paper was available. So uh, eh, that's why I was able to appreciate the beauty of that paper. Importance of the underlying graphs. You would have noticed it that we are able to calculate the smoothness of the graph with the help of the Laplacian one function f transpose multiply by Laplacian multiply by f. If you will calculate the value, what you will get? You will get, see, these three graphs are there. G1, G2, G3. If you notice, see in G1, see what is happening. All the values are positive on one side, and all the values after one node they are negative. In G2, if you go here, here what you observe that yes, see here one connection is there. So here there is a more fluctuation. When we move from the one node to the another, there is a more fluctuation from the positive to negative in the graph 2 structure. In the graph 3 structure, even see the values are same, but the linkages are different. Are you able to notice this linkage? See, this is same here, but this linkage is not in the G1 and G2. Structure is G1 and G2. So when you will basically plot this one, when you will plot the graph Fourier transform, what you will observe, see this beauty will be observed that here the more frequency components are available in the graph G3. Here in the G2 it is less components, and here only the low frequency components are available. So that's how you begin to appreciate, see what is frequency, what is basically the transform, Fourier transform, graph Fourier transform. There, here, the other concepts like filtering, etc., which we introduced you yesterday, see that has been explained. But remember, these are only the proposed concepts. The actual mathematics, how they will really lead to the thing, that will come when you will begin to apply these things in a specific application. So this is a thing, this is built in vertex domain, this is their example, they have proposed it. Some cameramen, see what did they say, that when you see the graph filtered picture, it is far better than the other picture. But remember, I tell you that when I was trying to actually implement that example, it really took me a month, 1.5 months to go through it. Because see, whatever things they are telling here, it's not easy to implement. It's because it is really difficult. Even see, I have to write a one time to the one of the author of this paper, sir, I am implementing it, but still I am finding the difficulty. So then you would be surprised that he proposed that you shift to the another good PC, where which has a more memory. Remember, those actually are not basically feasible solution. Somehow I couldn't apply that example, but I had some clarity. So convolution, what does the convolution look like in the graph signal processing? That concept has been proposed here. Translation, see what do you mean the translation, how it has been there. But remember, the actual thing will come only and only when you will begin to apply in your application. This is the graph portioning. How do you reduce the graph? How do you downsample? What is basically the localized multi-scale transforms for signal on graphs? Even I have not able to touch many things. Here, see, this is basically a heat diffusion operator is there. So here, they are basically using the graph spectral filtering. And what they have done here, that after representing the signal in the form of the graph, they have shown it that it leads to the some enhanced information. So this is basically summary. This is basically the temperature data which we noticed yesterday. And thereafter, he see the beauty of this paper. He shows the open issues. That these are the open issues. That's why you are things are not directly applicable. So, but see what happens when you go through this type of paper, it really helps you to begin to think about the basic concepts, begin to extract out the relevant information from any data. Uh, so either you understand or you don't understand, but you must go through this paper. It's a very, very good paper. Even if I say before my thesis, this is the only paper which the only resource available. So uh, if you have anything to ask in this one. So if you have any question or anything regarding this paper, you can ask it. Title of the paper, yes, see, it's, I tell you, this is the paper which I have read the most in my life because that is only available to me as the thesis. You can see, is it visible? So is it visible? I write it here.
Emergency state.
But see, I would, but remember, see, even I'm telling you, whether I'm only able to understand only the 20-30% of the paper, but it gave me such a confidence in the field of the GSP that today I want to apply the GSP in everywhere where it is available. So many times, see what happens that you are not, because see, even when I begin to implement these examples, try to be, see, usually what do we feel that whatever thing we should implement it fully in a one go. But see, even when I try to apply it, I face many difficulties. And even see when you ask the paper who have written it, they also provide you such an feasible solution. It really becomes difficult. So that is the. But what I am suggesting you, you must go through such a papers at least uh, for a 10 minutes daily. So any other thing, or we should move to the our next topic. I will also share you this paper. It will be shared. If you don't have, so we move to the next topic. See, important thing, what I want to give the message that even if you are able to understand 20%, 30%, the confidence which you get from reading the things, from implementing the things is immense. It is uncountable. Forget the thing. See, it's not a very simple problem where you can solve the thing and you can be confident. In actual life, it is a bit different. And in research scenario is very, very different. That's why I want to tell you people very clearly uh, about the things which are basically the misinterpretations that that people think that I would be able to fully understand the any reference, any general paper, but it is not so easy. But yes, definitely when you go through the paper, it gives you many, many insight, which provide, which help you in implementation of the concept, thinking about the concept, and framing the new thing. So now we come to the another topic is the screen. Is it now visible? So what we are saying here, so this is basically so now see this is work is basically the facial recognition, right? As we it is basically again the extension of two things. The topic which we started on the first day, that is basically the image processing. In image processing, facial recognition is the one. So this is again the work of my research student Manisha. She is done it. So coming to the face recognition is a see, very very famous application today. Nobody has the time to remember the password to open um, their phones. So what is the best way? Your face is there. And what is the good thing in face is that it's unique. Almost it is unique. So it can be used as a password. So that's why in the many, many mobiles, they only you simply show the face and it captures and that it is working as a key to open the phone. Before going towards it, there are many biometric methods for person identification, that is iris, palm, and fingerprint recognition. However, they require physical contact or proximity to the sensor. But face recognition doesn't require it. Is- And I also tell you the history of it that this topic was selected when COVID basically had just started. In 2020, Manisha actually joined in 2019, and at that time, we had been thinking that what can be the good topic. So at that time, we framed that face detection can be a very, very good one, where you don't touching part and etc. There should be a minimum physical contact. So that is also COVID-19 has also a contribution to suggest that topic. At that time, it was selected. What happens in the say facial recognition? It is image data is there. In image, basically, first you find out the face, and thereafter pre-processing, and then feature extraction, feature selection, face identification, and verification. See, if you people would have been observing, the best part of signal processing is that it's the same diagram, but it is such a you say the deep impact that every time it gives a new type of result. Whether if the signal is EEG, it is another one. If signal is ECG, signal it is a simple image because so only one simple concept But once you begin to apply it, it gives you lot and means always a new result. So now coming to the face identification verification, we should be very clear that both the things are different. In face identification, it is compare the given individual to all other individuals because it is that person centered only. In face verification, it is basically compare the given individual with whom they claim to be. So one-to-one matching, one-to-many matching, it is one-to-one face verification. Output, it is a face ID or that person in face verification, it is binary classification that it is match or unmatched. Yeah. Classifier used here, similarity is used because here you basically use a threshold, etc. and face recognition algorithm. So these are the things. Face identification is used where unconstrained scenarios are there, and face verification within constrained scenario. Where it is the application, it is basically the CCTV control, power grid surveillance, monitoring and searching from drug offenders and known criminals. Even see, you people would be surprised to know that, um, surprised or even it's interesting to know that on the airports also. See, for example, when you are going to the some countries like Europe, etc. So you have to go in a separate line and you have to register your face. So as soon as your face is registered, so whenever you are at any place, either in mall, etc., they are able to know that this person has just landed in this country before 2 days, 3 days. So that is the thing. Heavily used algorithm, criminal justice system, post-event analysis and forensic, image data sets, investigation. It is search. Even see, you people, are you aware? See, even Indian government is also now using this space. Where very very recent application, not only abroad. Uh, are you able to connect? Recently, one application of face verification has come out. I hope you would be. Any guess by anyone? See, have you are aware about this word, Digiyatra? See, what you have to do this basically, this is app is there, and I hope see many would have used it. See, one app is there. So while the airport check, either you have to show to the Aadhaar, etc., everything, or you can just in the DigiYatra app simply upload your Aadhaar and you scan your face. So as soon as you go into the in front of the machine on the airport, it quickly scans your face and automatically gate opens. There is a separate queue for the DigiYatra. Simply based upon the face recognition, your every Aadhaar check, etc., is done automatically. Even people are preferring it. Why? Because you don't have to be in a long queue where when police personnel where the security personnel checks manually. Yes or no? Has anyone used it? Did Digi Yatra? Yes or yes, Srija has used Devashi. Very, very good application. Facial recognition. Anyway, see, coming to the part, this is a so criminal just so image data sets investigation, human computer investigation, smart card application, video index, and civilian application. What we are saying, one motivation, control people stand in front of the camera with good illumination condition, What about attendance, access control? Remember, whenever you want to have a face recognition, you should also have the illumination condition that is important. It should be now. It is also the part of the controlled environment where people photo capture on random places like mall, airport, and traffic area. It can be both the way, face recognition. Simply in front of camera for in the attendance, etc. It is a good thing. But also we try to capture the photo, for example, like in the CCTV, when we are recording it. We want to identify the person in random. So what are the challenges? See, whenever as engineering we discuss it, so where do we face the difficulty? The difficulty is basically first difficulty is basically the occlusion. What do you mean with the occlusion? Occlusion means basically some part is not visible. So another is facial expression because another is illumination, another is pose variation. What is saying, see, external occlusion means you are, for example, you are seeing this lady. When you are seeing this lady, its full face is not visible because it is uh, basically covered by the another person. In the self-occlusion, what do you mean self-occlusion? Self-occlusion means that the person is basically standing in such a way that it is non-frontal view. Because see, what is our purpose? Our purpose is basically when we are watching when we are seeing the recording of the CCTV, etc., we are able to identify that which person was there, what activity was he or she doing. Another problem is the comes when it is head sunglasses, etc., are in at the face. Then it is limited field of view, partially out of camera. See, sometimes camera full image is not captured. If I want to notice this person who is in the extreme left, sometimes it is extreme illumination. Otherwise, so in that scenario also it is not easy. Then it is sensor saturation that also becomes happen. So different occlusion conditions in this picture has been shown so that you can understand it. Here, somebody is wearing the sunglasses, somebody his face is basically covered. So what is the way? Way is basically to remove out these sunglasses from the picture. Here you have to reconstruct the image so that the person's face can be visible. In the same way, the here person's complete face is not available. There also you can find out it. So this is basically thing. Occluded free faces. This is a solution, and the upper level it is occluded face. So public data sets. Whenever you are working upon any research problem, for see the data sets where you can apply those things. So here different data sets are there, AR, extended LW, ORL, parent, LFW. This is the one. Occluded face recognition. See what approaches are there. One is basically the robust occlusion face recognition. Another is occlusion aware face recognition. And then it is occlusion recovery based face recognition. So what is basically robust occlusion face recognition? In this case, see, we whatever even some occlusion is there, but we want to recognize the face, keeping that occlusion at that place only. While in the occlusion aware, see what do? We detect the occlusion and discard face recognition. Here part. So see what do? We actually remove out that area. So only the partial face is available. In the robust occlusion, full face is available. Even something is occluded, it will be used for the training. While in the occlusion aware, the part which is occluded, we will remove it. While in the occlusion recovery based face recognition, here if something is occluded, we want to recover back. We want to uh, reconstruct that occluded area. So that is These are the three approaches here. So these are basically the research gaps. What are the research gaps? Basically, in exist. Again, so these are the research gaps in the phase occlusion. So here the existing feature extraction methods struggle with occlusion. Traditional method like the local binary pattern, histogram of gradient, and scale invariant feature transform degrade performance under severe occlusion because they extract holistic feature from the entire phase. Deep learning models extend global feature representations which may be distorted by occlusions, reducing recognition accuracy. Limited attention to occlusion resistant feature. See, you people, are you aware about this local binary pattern, histogram of oriented gradients? Have you gone through it? Are you aware about LBP? How many are aware of local binary pattern? HOG. See, why am I asking? Because if you have not gone through it, I will ensure to arrange it in some lecture. Otherwise, any answer? Are you here with me? Krishna, Ritesh, Devaki. In past but not record now. Okay. So I will have the time. What about other? See, basically local binary pattern, what do we do here? We based upon the centered pixel value, other value, whether it is less than it, if it is less than, then we mark it 0. If it is more than that value, then we mark it as 1. That's why it is local binary. The central pixel value which we compare with we take a 3 by 3 block and all the block is converted into the form of 1 and 0. What about HOG? Are you people about HOG? Yes, Suman is right. LLP HOG. Use for yes, correct. What about is everyone aware? Because I hope these are simple concepts. Try to go through it if you find, or we can have the one session over it. We come to the part. As you may see, you will go through it, and if you find difficulty, you can ask it. What we are saying here that limited attention to occlusion resistant feature. Some method, other methods are there. Local Gabor binary pattern, which attempt to ignore occluded areas. So here what did we do? We basically graph-based feature extraction techniques have been proposed. So what are the basically research objective? Again, see what work is, again it is the work of the Manisha, see how she has basically done, explore different feature extraction selection method, developed a robust feature extraction technique that uses patch-based learning to extract robust feature. Design an occlusion-aware recognition model that extracts the occlusion part using the graph signal processing. So thereafter, we came out with a thing that we small scale dataset learning. See, at maximum places, basically deep learning which has been used. But in deep learning, see, you should have either that much data available, but that much computational facilities available. But in the signal processing, you have the advantage that you simply require the good feature extraction. And then simple ML algorithms will provide you the very effective solution. So that has been suggested here that small scale data sets can be used for occlusion based face recognition. Occlusion segmentation with graph signal processing. Here, a graph cut method has been proposed that extract occluded part while maintaining relationship between non-occluded and occluded region. So only the key thing for graph signal processing, once you are able to define a signal where you are able to define the edges and their weight. Once it has been defined, then your graph signal is available, your W is available, and then you can find out the L, Laplacian metric, GFT, and the GW. So, what are the earlier things in the facial recognition? Here, you can see here that in the face recognition approach, it is the three part, it is a robust feature, it is occlusion detection, and then discard that part. Another is partial face detection and partial face recognition. So what has been shown here in handcraft features, it is a local binary pattern is there. So divide space into multiple regions and extract LBP feature distribution. So see, what is available in the LBP that the relative neighborhood information with that central pixel. Features are concatenated to form a global descriptor as it is basically texture-based descriptor. LUP alone may not capture all facial details effectively, but mainly the text effort. Another is weighted chi-square distance. It measures distance between two LBP-based face descriptors. Some facial features are more important than making the weighting crucial for accurate recognition. Then the another one is a scale invariant feature transform. Shift that basically detects the key point. If you people feel it that yes, if I need to go through the shift HOG, I will. Please let me inform. We can go it. What is the thing here that they are the key point? You identify the key points and on based on these key points, you either classify the image. Then basically histogram of gradient and histogram of gradient. It is gradient Gradient means basically the angle. That how much inclination is there, all the different pixels. The gradient of your edges. So that was again, and here you are using the histogram. So how many, for example, mm, gradients of 60 degree, 40 degree, 30 degree, how many are present? Earlier we have been limiting ourselves to the only pixel values, but here now we are calculating the gradient. This is a Gabor filter. It is the old approach where you extract the face feature representation based on frequency. Local Gabor binary pattern, which mainly the Gabor normally focus upon global information, but in local Gabor, the neighborhood information comes out with the help of the LBP. So another method basically patch feature matching and patch you because if you instead of going by pixel, you take the patch. So here different methodologies are there. Some is graph based matching, another is local descriptor based matching. So then in the subspace also, for example, the PCA is there where you select out the key components, linear discriminant analysis. Many times see these techniques are used after applying the basic feature recognition. For example, if the size of the feature vector is higher than PCA, LDA becomes very crucial to reduce the size of the feature vector as well as improve the efficiency. So another are the stress trigger parameters. And stress trigger parameter it is mixture of Gaussian preclusion compensation. See, all these are self-organizing maps are there where spaces, subspaces are represented to map simulate a relation between subblocks and class by pair. Local Gaussian kernel with SPM. So these are given a sparse representation classifier, Gabor feature-based robust representation classification, a sparse and dense hybrid representation framework. So based upon the accuracy and the low processing time, we select one or more than one to move on the strategy. And the sparse representation classifier, it is robust and discriminative low rank representation which capture the global structure and holistic structure of occlusion. Discriminative multi-scale sparse coding, hierarchical sparse and low rank regression model. It also uses image gradient features for weak low rank optimization, nuclear norm-based adaptive occlusion, dictionary learning, structural element feature extraction with adaptive fusion, and few short sparse representation learning. So this is, I think, all for we will start from the deep learning. Not today, tomorrow in afternoon we will have some another session basically by the faculty professor Dr. Hanuman Singh Shekhawat. He will discuss the new topic we will take up tomorrow if you have any question.